This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. A particle is moving in a circle with centripetal force F is equal to minus k by r square. So what is the total energy associated with it? So I just first draw the figure pertaining to this, and so what will be the figure? If a particle moves in a circular motion, then the centripetal force acts towards its center, and it is given by Fr is equal to mv square by r, where v is the tangential velocity at a point, that is v is equal to r omega, and omega is the angular speed. So if you have any doubt about this thing, you just go through my notes in the circular motion and you will learn more about it. So it is given that the centripetal force is equal to minus k by r square. So from that we get the value of mv square by r, which is the centripetal force, and is equal to k by r square. So it's from there we are taking only the magnitude of the centripetal force. So from there we get mv square is equal to k by r. So clearly the kinetic energy is equal to half mv square, and if I put the value of mv square, then we get the value of kinetic energy is equal to k by 2r. So this is first equation, that kinetic energy is equal to k by 2r. Now we will calculate the value of potential energy, and the potential of for the potential energy we know that du by dr is equal to minus f, that is the potential energy. If we differentiate the potential energy with respect to r, then we get the force, and clearly here the force must be equal to conservative force, as only conservative force accounts to the potential energy. So from there we get du is equal to minus f into dr, and if we integrate it we get the value of potential energy. So how we will integrate it? See, at r is equal to infinity, that is when the particle is at the infinity, then there is no any external force, or the potential energy of the system will be equal to 0. So at r is equal to infinity we consider the value of potential energy equal to 0, and when r is equal to r we get the potential energy equal to u. So from there we get 0 to u du is equal to infinity to r f dot dr. So I just put the value of f, and value of f is minus k by r square. So if I put the value of f, then infinity to r k by r square dr. Now we have to integrate it. So how we will integrate it? Those having no idea about the integration, I will just write down the formula, that if we integrate xn, then we get the value is equal to x raised to power n plus 1 divided by n plus 1. So it's equal to infinity to r k into r to power minus 2 dr, and on integration we get k divided by r with a negative sign, and the limit will be infinity to r. So the value is equal to minus k by r minus 0, and it's equal to minus k by r. On the left hand side it's in u minus 0 is equal to minus k by r, and from there that the potential energy is equal to u is equal to minus k by r. This is equation 2. Now we have to calculate the total energy. So total energy is equal to sum of potential energy plus kinetic energy, and if we add equation 1 and 2 we get the value of total energy. So value of total energy comes equal to minus k by 2r. So total energy is equal to minus k by 2r. So this will be our answer. Next problem, that the potential energy function describing the interaction between two atoms of a diatomic molecule is ur equal to 1a divided by r raised to power 12 minus b divided by r raised to power 6. force acting between them will be 0 when the distance between them would be. So you have to calculate the distance between these two atoms. Let us suppose these are two atoms of a diatomic molecule, and the potential energy is a function of a distance between them, which is equal to r, and it is equal to a divided by r raised to power 12 minus b divided by r raised to power 6, and you have to calculate the when the force between them will be 0. So as we know that the force is a function, if the potential energy is a function of r, then the force is equal to minus du by dr. So we will use this formula to get the value of force between these two, and we will equate the force equal to 0. So if I differentiate u with respect to r, what value we will get? We get du by dr is equal to a into minus 12 r raised to power minus 13 minus b into minus 6 r raised to power minus 7, and it is equal to minus f, which must be equal to 0. So from there we get that minus 12a divided by r raised to the power 13 plus 6b divided by r raised to the power 7 is equal to 0, and 6b by r raised to the power 7 is equal to 12a divided by r raised to the power 13. So from there we get b by r raised to the power 7 is equal to 2a divided by r raised to the power 13. So we get r to the power 6 is equal to 2a by b, and r is equal to 2a by b raised to the power 1 by 6. So if you see the option, then option A is correct. R is equal to 2a by b raised to the power 1 by 6. So answer will be A. And this is the problem of the comprehension type. When a single conservative force Fx acts on a mass m is equal to 1 kg particle moving along x-axis, the potential energy Ux is given by Ux is equal to 20 plus x minus 2 raised to the power 2, where x is in the meter. At u is equal to 5 meter, the particle has the kinetic energy equal to 20 joule. So you have to calculate the various problem based on the information given. So first we will draw the figure and then we will solve this problem. So suppose the particle is moving along x-axis, which is given, then this is the point x is equal to 0 and particle is moving. So at x is equal to 5, the kinetic energy is equal to 20 joule. Again, the potential energy is given by the function u is equal to 20 plus x minus 2 raised to the power 2. So you have to given that much information. Mass is given equal to 1 kg. Then first thing you have to calculate the total mechanical energy of the system. As this is working, the force is the conservative force, so no energy is lost due to friction or anything. So we may say that at any point of time the total mechanical energy will be conserved. So how we will approach it? So at x is equal to 5, first we will calculate the potential energy. So potential energy at x is equal to 5 and it comes equal to 20 plus 5 minus 2 raised to the power 2. So 20 plus 3a square and it comes equal to 29 joule. So at point x is equal to 5, we have kinetic energy is 20 joule, potential energy is equal to 29 joule, so total energy will be 49 joule. So at energy at E at x is equal to 5 is equal to 29 plus 20, that is 49 49 joule, and this energy will be constant throughout the motion. So as per the conservation of mechanical energy, so total mechanical energy of the system will be 49 joule throughout its motion during this. So you have to calculate next the minimum potential energy of the particle. So the potential energy will be given by U is equal to 20 plus x minus 2 raised to the power 2. So clearly the minimum value of potential energy will be when this term inside the square will be become equal to 0, as potential energy must be equal to greater than and equal to 20, as this term inside the square will must be equal to positive, either positive or 0. So at x is equal to 2, we have a minimum potential energy which is equal to 20 joule. So minimum potential energy is at x is equal to 2, we have U is equal to 0, sorry, U equal to 20, and kinetic energy will be equal to 29 joule. So the minimum potential energy of particle will be equal to 29 joule. Now you have to calculate the maximum value of potential energy. So how we will calculate the maximum value of potential energy? So maximum value of potential energy comes when the kinetic energy remains equal to 0. So consider at the point here, consider at the point x or x1 where velocity is become equal to 0. So at the point x1 the velocity will be equal to 0. We term this point as a point D. So at point D velocity will be 0, and at this point the kinetic energy will be equal to 0. So at point D kinetic energy will be equal to 0 and potential energy will be a maximum value which is equal to 49 joule. So when the velocity will be 0, then the potential energy having the value equal to 49 joule. So in fact you can calculate the value of x also. So if you want to calculate the value of x where potential energy will be maximum or the velocity of particle will be 0, you just keep the value, you just put 20 minus x by 2 raised to the power square, which is the formula for potential energy, and equate it equal to 49 joule. So from there we get x minus 2 raised to the power 2 is equal to 29 joule or 29, and from there we get x minus 2 is equal to plus minus 29, and x is equal to 2 plus minus 29, sorry, square root 29. So if we consider this side, then this value will be equal to x1 is equal to 2 plus square root 29, and similarly if I come to the left hand side of it, then at a point x2 we consider this point as a point x2, and at x2 is equal to minus square root 29 plus 2, with the point at which the value of kinetic energy will be equal to 0. So we term it equal to E. So clearly at the point D and E the potential energy will be of maximum value equal to 49 joule, and these 2 point is equal to square root 29 plus 2 and minus square root 29 plus 2 respectively. So again the next thing, you have to calculate the maximum speed of the particle. So you have to calculate the maximum speed of particle. So at maximum speed we have the maximum kinetic energy. So we have already calculated the maximum kinetic energy is equal to 29 joule, because the potential energy is equal to 20 plus x minus 2 and square, and the potential and total energy is equal to 49 joule. So we get the maximum kinetic energy at x is equal to 2, we have Ke max, and it is equal to 29 joule. So you have to calculate the maximum speed. So maximum speed is half mv square equal to 29 joule, m is equal to 1, so we get v square is equal to 58 and v is equal to square root 58 meter per second. So maximum speed of particle will be square root 58 meter per second. And what is the minimum speed of particle? So minimum speed of particle we have already covered, that at the point, if this is x is equal to 0, then at the point D, which is the x is equal to square root 29 plus 2, and on the left hand side if you consider this point E, then the value of E is square root minus 29 plus 2. At this point D and E, the speed will be equal to 0, so maximum speed of particle will be 0 at this point, and at these 2 points we have the maximum potential energy. So the next problem is that you have to calculate the least value of x. So least value of x we have already calculated, minus 29 plus 2, and we have already calculated the maximum value of x is equal to plus 29 square root 29 plus 2. I just first draw the figure here also. These are the point D and E, and D is E is equal to minus 29 plus 2, and D is square root 29 plus 2. And you have to the last part of this, then the position of equilibrium and its nature is. So 2 points are given. Then first is that the x is equal to 0, x is equal to 2. So you have to calculate that at the point x is equal to 2 you have what kind of equilibrium is that. So as per the formula of potential energy, U is equal to 20 plus x minus 2 raised to the power 2. So clearly the potential energy is minimum at point x is equal to 2. At x is equal to 2 we have value of potential energy equal to 20 joule, and it is the minimum value, and the minimum value of potential energy corresponds to point of stable equilibrium. So at x is equal to 2 we will have a stable equilibrium.